So the problem is we need to have a food balance that's dynamic, that can grow and can shrink based on what selections the end user takes. Um, so in order to do that, we defined that there was their inventory level, how much food they have on hand. We have to look at their family size, how much each individual or how much food each individual needed, and then what their actual food need was. And the output that it would give us in the end would be, a function of all that would be the food balance. So what the code looked like, I guess the pseudocode down here is we'd have a food need, which was equal to our family size times our individual food need. And then, excuse me, we'd have the inventory food need if that was less than one, or if it was greater than 500, that was the boundaries there, then it should give us a -1. Um, if the family size was less than one, then we'd have to have it, give her a -2. We can't have a family size that's negative. If or zero, I guess in that case. If individual food need is less than zero, then it returns 3 because the food need can't be less than zero. Um, and then if the food need, or excuse me, so if the individual food need was less than zero, that's an error. And if the food need is less than zero, that's an error. So then our food balance in the end would be equal to our inventory food minus the need. So what we have on hand minus what was needed. If the food balance is greater than zero, then we give the actual food balance. Otherwise, we'd give a zero. So those cases, I guess, tests of all of these.
And
Like
this is your actual test matrix right here, right? No,
well,
these
so
are your test cases. I see. Okay.
yeah, test cases. So this is the test matrix. These are test cases. So for each of these inputs, we should get the following outputs. So this one was, totally valid. Everything here works. We should get a 60 out of that. The next three should return negative, 1, 2, or 3. And if you look up in the code, we have a -4, which really shouldn't ever happen because food need is a function of individual food need. We just put it in there to trap it just in case anything ever happens. But really, if the individual food need is -1, or if the family size is -1, or any negative number for that matter, food need would end up being negative. So, like I said, if somehow randomly food need ends up being -6, it'll return a -4. Um, but for the cases that we have here, we see it's going to give us an actual number. We should be fine. Then test our boundaries. We have, a minimum of 1 here. We've got our max of 500. So we can see what the result would be based off of those. Things in the middle here. Everything's all good. Max family size, or excuse me. Yeah, this is just something in the middle for us. And then something more on the upper bounds.
Okay. So go ahead and show us that in your actual code now, could you?
Yep. So back to our food
All the way down at the bottom.
test. Well, are we going to show this guy first?
Oh, I guess we can, yeah.
So translating that pseudocode into code, you see here, it's pretty much just like the pseudocode in the end. We just call it individual or INV food. So inventory food, either less than 1 or greater than 500, we're going to get a -1. If our family size is less than 1, we'll get the -2. If the individual food need is less than 0, it'll give a -3. And if the food need is less than 0, it'll give us a -4. We have our food balance, which is going to be returned as an integer. We're not going to have partial pieces of food here. So that food balance is equal to our inventory food minus our food need. And then if the food balance is greater than 0, it's going to give us the total food balance. Otherwise, it's just going to return food balance as a 0. So that if there's any other return, anything else gets trapped at 0. If it's an actual food balance that can be calculated within the boundaries we provided, it'll give us the actual food balance. So that's what the code looks like. To test it, just come down here, go test file, and this might take a little bit just because my computer's a little slow. Test path, test 1, test 2, 3, 4, 5, 6, 7, 9. There they are.
Excellent. Okay, and then this is kind of an everyone thing, but I'll go ahead and do the next part if that's okay. The last part is just display changes, or show how you can actually put your changes up to the cloud. So all you need to do is click on the particular package that you're trying to do, or the particular class, depending if you want to do the whole package or the class. You right click on it, do git, commit, make sure that it's the correct one, and we'll just amend the last one so that we can show you. Click, it goes through with the commit, and then you go remote, push, and well, team remote push. Make sure you're in the right one. Next, and click the master one, and then click next and finish. I'm not going to do it right now because I don't know the different changes that have been uploaded, but because I haven't pulled first, but that's how you do it. So here we have a couple different selection statements that we actually used inside of our start program view. And the first selection statement that we see is a do loop. The reason why you would want a do loop is in case you wanted it to execute every time and you wanted it to do something before it checked its parameters, as long as one parameter was correct, was still something. So in this case, it's while end of view is null, which we set it to null at the beginning, it's always going to do this loop until end of view equals, it's going to return end of view as either true or false. But until basically, well, until it returns the end of view being true. Over here we have a while loop. Or no, that's the do while loop. My bad. Over here we have the if statement. Now the if statement is when you want to do something and you kind of want to check the parameters first before you go ahead and do it. So this is if player is null, then you go ahead and you system.out, please enter a different name, and then return false so that we can go back to our do loop and continue executing.
You have a if else statement you can also use up above that in your do while.
Oh yes, we do have the if else statement inside of the do while loop. Yeah, good point. Or good pointing that out.
Devin already explained a little bit the do while loops and the if else statements there. Next selection statement we want to talk about is the switch statement. So this is what we've been using for if we have a list presented for the end user. Hey, you need to pick one of these options, and then based off that, it'll direct you to the next piece of the program. The way this switch statement is going to work is based off of the inputs that it's gathering from this do while loop up above, where this is really just scanning the keyboard, seeing what they pressed, making all of their whatever their input is uppercase.
Well, to a string in that case.
Oh, sorry, in this string in this case. Uppercase is the one you went over.
Yes.
So, yeah, this one will create a string out of it, out of what their input is. So from there, you know, if what they entered was V, for example, it's going to run the view map function, which is located down here below. For the meantime, this isn't completed all the way. We still have to do the map class, but it's going to run the function here. So, I mean, really what it does is based on whatever the input is, it's going to look to see which letter it matches up with, or in the case that it doesn't work, that it doesn't match up with anything, the default for it will say that there was an error, invalid selection, please try again. So it's going to print that out. And it'll return false, so it'll bring the menu back up again and allow the user to still continue to use this. In the case of Q, so all of these should return false afterwards. However, in the case of Q, it's going to return true, which would mean that it would exit the program.
All right, so I'm just going to go over the if statement and the different options that it can return depending on what is returned with the check speed. So here I was working on the player health and to see how it is affected by how fast we're going. So first we check speed, and then we get the speed. And depending on whether we're going slow, medium, or fast, slow would be 1, medium would be 2, and fast would be 3. So these are just checking to see if the boundaries for it. So if speed is less than 1, we're going to return fail. If speed is more than 3, we're going to return fail. And then if not, it just returns a pass. And this if statement just checks if we rested, we return 20, which would add to our health. And if not, we return 0. And this class changes our health according to how fast we were going. So we would get the speed, and then we would get the health, and we would go through the if statements. So if speed was 1, our new health would be reduced by 10. If our speed was 2, our health would be reduced by 20. And if it was 3, our health would be reduced by 30. And
This is another one checking the boundaries. If it's underneath 20, then it's just going to go ahead and print out a message, you have fallen L. Yeah, that's something that I added in, so I know you don't really know about that one, but
good call. Good admin.
yeah.
Love it.
And so I'll also state just a little bit that the difference between like an if-when statement and a case statement is that a case statement has many different cases for when or for like what could be input into your code. It'll spit out, one of many different circumstances. An if statement will go ahead and run through everything from top to bottom, trying to find it until it finds the one that it matches with. And it's more for when you have less options and when it's more simplistic, what you're looking for, a yes-no answer, a true-false answer, things like that.
One more thing to add to that is you can make an if-else statement do the same thing as a case statement. It's just a lot more inefficient.
Takes
like
a lot
Devin's,
more writing.
Yep, a lot more programming, a lot more thinking through. So it can be done, but definitely not recommended.
Okay.
So after I completed that, I created a test unit for it, and here we're gonna run it and see if there's any issues and to see if it passed all the parameter tests. We'll press test file. And it seems we passed all the boundary tests and the limits of the program.
Why don't you go ahead and also open it up and show it a little bit and just explain what it's doing real quick.
Yep. So this is test check speed number 1. So it's checking to see it's checking to see the boundary, the lower limit of it. So that would be if you would enter 0, it would return false or -1, and that's what we got. Mm-hmm. And then we also checked the upper limit, which would be 4. If we exceeded 3, it would return an error, and that passed. And We also checked the three different speeds: the fast, medium, and slow. And also we checked the
Now this is the test check rest, right?
yes. This is the test check rest to see if we input that we did rest, it would give us an additional 20 points of health to add on, and that passed as well. And this is also to see one was false and one was true. One would return 0 and the other one would return 20.
Okay. My turn now, right?
Yes, sir.
Okay. So, can you guys see my screen? I forgot if I'm sharing it, but anyways. I believe I kind of did purchase supplies, was that right? Or did I do location?
I think you did location.
Okay. So I did the test location, and so this one is doing the same thing. It's basically just checking the upper and lower boundaries of everything. So it's checking if it's in the negative, it's going to be a false result, or it's going to spit it back out that it was wrong. If it's in the negative once again, it's going to spit out that it was wrong, but if it was correct, it's going to spit out the answer that it was correct. Now with test change location, we only have one of these currently, but it's doing the same thing. It's basically just checking the rows and the columns and the speed and then what the expected result is. This one, in this case, all the parameters should be good because it's not actually setting any of these parameters, it's just getting all of them. So it's checking to see all the gets are good basically, and then it's going to spit out if it's worked or not. And if we come over here to our test file, we can see that we had ran 4, failure 0, error 0. That's because even when it was checking for a failure, it checked it and it was a failure. So that's a good test because the failures equaled to failures and the passes equaled to passes.
Had to do it. So scope has to deal with where the variable can be referenced and used. And the lifespan is when a variable is active in memory and can be used.
Okay. Thank you for that.
Scope is more of the where, lifespan's more of the when.
Yep.
Awesome.
So right here, in our very first part of our display game menu view is the display function. I always forget what they're called. The display function method thing. And so it's going to be calling or creating a Boolean end view. This is the new variable. It's called end view. It doesn't have to be initialized. Oops. It can be just end view, and you can take away the false, but the false initializes it so that it actually has a value when it begins. Otherwise, it's just going to be nothing. It's going to be there in memory, but it's not going to have anything put to it. The next one is a string array called inputs, and it is being initialized as null. And then the places where these things can be used and where they can be called is anywhere inside a display. So basically right here, anywhere in between these yellow ones, or these yellow highlighted brackets, it can be used if it's the Boolean or the string. However, it cannot be used anywhere outside of that. And once we hit the end of this, for example, once we hit the end of our while loop, that's it. They're going to die. They're not going to, I guess, yeah, they're going to die because their lifespan ends, and they're not going to be available for us to use anymore. But in the what it's going to be doing, it's going to be going through inputs, get inputs, and that's going to basically drop us down to the next get inputs function. But then it's going to check those inputs to see if they're queue, basically. And it's also going to try to return inputs in the do action. So, moving down to the get inputs. Who wants to do that next? The get inputs.
I'll take a crack at it.
Okay.
So, for get inputs, we'll just use your computer. Is that cool?
What's that?
Oh, I'm going to have you guide it.
Okay,
So
yeah.
for get inputs, the first thing that's going to do, we're going to define a string called inputs. Excuse me, it's a string array, I should say. So we're creating a new one. It has one spot assigned to it in the array, as you can see there in the brackets. From there, it's going to print out this, really just a string, this list. For the user to see, something that they can see when they pull up the program.
But something important to note, sorry, is that this string is a new variable.
Right, right. So that string is a new variable. Um, so we'll see it come into play here in a little bit. We also have a Boolean that we're going to create called valid. So valid is a new variable, and we're going to assign it a false. Um, I guess how would you say that?
Parameter?
The value of false.
Value?
Yeah. All right. So because that variable, that inputs variable was defined up above, we're going to see that we can use it here in this do loop because it belongs to that entire um, to this whole function. So uh, we enter the do loop as long as it is not valid. So as long as we're getting false, which currently, because valid, that variable valid is false, it's going to go ahead and start the do loop. So first thing it's going to enter, or excuse me, that's going to show is, please enter your selection. So the user will be able to see that list up above, and then they're going to be prompted to enter their selection. Based on the scanner keyboard, which that's going to check to see what they're putting in, what they're typing in there, and based on that, it's going to take that value and put it into the inputs array that we created up above. So it's going to assign the value of whatever they typed last into the inputs array. And then it's going to convert that into a string. So I guess it's taking what they put in there into that inputs array string. If inputs, whatever is in that position of input 0, if that string is longer than, I guess if it is less than 1 in this case, so if it's not empty, then it's going to say that there's, excuse me, is this right?
Yeah.
Oh, this is saying if it is less than 1, yeah.
Yeah.
So if it is less than 1, then it's going to say that there's an error because there should be something there. And then it's going to say that valid, that Boolean that we set up above it, still remains false. So it's going to bring up the list again, prompt them to enter their selection again. So we're going to continue doing this until they pick some selection that will finally return true, which would be a value greater than 1, right?
Yep.
So while that's valid, or I guess while it's not valid, in short, if it's returning false still, we're still repeating this. If it returns true, then we're going to get inputs. It's going to enter whatever the user entered.
And return that all the way back up to the do
Get
action loop that I was talking about earlier. But
Yep.
it's going to take those inputs inside of the do action loop, and I'll go ahead and let Nick explain what the do action loop is doing here, and explain about the variables.
Right on. So in the this do action, it takes the input from what Hans was explaining, and it puts it into action. So right here we see the string menu item equals input. So our variable would be menu item, and then it would switch into uppercase, and then it just goes by, it does a case switch to see which input was put in, and then it gives us the, I guess the new screen that's gonna pop up. And if nothing is, if not a proper character is selected, it's gonna return error to us. And when it returns, then that's the lifespan of that variable.
Okay, exactly. So as we can see, we had one variable whose life kind of got passed around here, which was the inputs variable. But we always had to reassign it to something when we were working with it and make sure that it still had its assignments But then once it came down to it, it got passed back into where it needed to be. So it got passed back into get inputs, and then it got passed forwards into the do action loop. Is that right? Am I saying that pass back then forwards, or was it forwards then back? Anyways, I think you get what I mean. As a team, you create examples and explain a strong understanding of how arguments are passed by value and passed by reference.
I think that's kind of what
We kind of
isn't it?
did that with the inputs.
I think so
Yeah, I
too.
think we did.
Yeah. So I'm going to click stop recording unless you guys have anything you wanted to add.
Just please give us an A.
Forgive me.